Alright, so at the bottom of page 344, we're going to go over a few examples that highlight how we can actually determine the value of that mysterious constant c on the end after we find an antiderivative. So, taking a look at number 1, if we just take a look at the information we have, we're starting with a second derivative equation. And we're also given some information about a first derivative value and an original function value. And our ultimate goal is, starting with the second derivative, we want to figure out what the original function was. Okay, so if you think about it, if we're starting with a second derivative and we want to eventually get to the original function, we're going to have to work backwards 2 times. Because if we only work backwards once from the second derivative, that would represent the first derivative. So we'd have to go backwards again to eventually get to the original function. So let's think about this. If I start with my second derivative equation of 2 and work backwards from that with respect to x, notice how that's the variable they listed in the function notation, I am going to get 2x plus c. Okay, so this was representing a second derivative, and if I work backwards from that, I'm going to get a first derivative equation. Now, this first derivative has that constant of integration on the end, but notice how we do have a particular point value from the first derivative function or graph available to us, so we can actually use this point to help us out. It's telling us if I were to plug in 2 for x into this first derivative, I should get out 5 as an answer. So I can set up an equation, okay, 2x, actually maybe I'll just put in 2, because that's what my x value is. So if I plug in 2 for x, my answer should be 5. So this is going to be 4, and if I subtract it over, looks like my c value is 1. So my actual first derivative equation is 2x plus 1. Notice how that's much more specific than this c on the end would be, because this is just telling us it could be any constant. The fact that we have a point available to us means we should be able to figure out what that constant actually is. So if this is a first derivative, I want to work backwards from this to get a original function available. So if I work backwards using our reverse power rule, I'll have x squared plus x plus c. Okay, again, this 2x plus 1 is a first derivative, and if I work backwards, x squared plus x plus c is representing the original function. Now I do have a point available from the original function, so I should be able to figure out what c is. If I plug in 2 for all those x's, I should get an answer of 10. So it looks like my c value is 4. So in the end, we can say that the original function was x squared plus x plus 4. Okay, so this equation with these particular constants satisfy the points that were given to us, but also the second derivative in the end. All right, let's go and try another one. Notice how this one's kind of set up the same way, but the second derivative function is a little bit more involved than just this number of 2, but the thought process and the work is going to be very similar. So I'm going to work backwards from my second derivative function. All right, now reverse power rule, I'd have to add 1 to the power, which would be negative 1/2, and I have to divide the coefficient of 1 by this new power. So 1 divided by negative 1/2 would be negative 2. All right, now I'll have my plus c. So if this integrand represented the second derivative, then this result, aka antiderivative, is the first derivative function. Okay, in general form, because we have that plus c on the end. But we do have a point value that we can use, so it's telling us if I were to plug in 4 for the x, I should get out 2 as my answer. So 4 to the 1/2 power is saying a square root, so the square root of 4 is 2, and since the power is negative, that means I can reciprocate that answer, which would make it 1/2. So 1/2 times negative 2 is negative 1, and solving for c, I'll get 3. So my first derivative function is negative 2x to the negative 1/2 plus 3. Okay, our ultimate goal though is to get f of x, so I'm going to have to work backwards another time. Alright, let's try this. So reverse power rule, I have to add 1 to the power, which would be 1/2, and then divide the coefficient by this new power, so -2 divided by 1/2 would be -4, and then working backwards from 3, I'll have 3x. Alright, so this is representing kind of a general original function that we had, but we can figure out what c is because we have an ordered pair available to us. So basically, if I were to plug in 0 for those x's, I should get out 0 as an answer. And notice how these x's would go away, so c would have to equal the answer, meaning 0. Okay, so it looks like we don't really have a constant on the end, which means our original function is -4x to the 1/2 plus 3x.